I was thinking about growth rates recently. So, if basically looking at different countries, and wondering what was going to happen in the next few decades. And that's where logs play a role. So the basic question that I was thinking about was, how long is it going to take for various countries to double? So how long for GDP, so I'm talking about the economy, to double? And this is what I got. So basically, if a country is growing at 5% a year, it'll take, say, nearly 15 years for the economy to double. If you think back, though, that's a while back, but Ireland in the 90s, maybe even early 2000s, was growing at 8% a year, which meant that in less than a decade, the economy doubled. While many places in the developed world at the moment are growing less than 2%. So if the economy only grows at 2%, it'll take 35 years for the economy to double. And what that means is, during your working life, if the economy remains at 2% or less, things are not going to substantially change. That you're not. It's quite static. Whilst if you're in a booming economy, so in many of the emerging markets, you'll have 7-8%, that kind of growth. There you'll be able to see in front of your eyes that within a few years suddenly things have dramatically changed. Now, of course, economies don't remain static, so this isn't an amazing model. It's you don't get to maintain 8%, 9%, 10% growth for decade after decade, unless you're China. But it's just, it just puts things in perspective, that you can kind of see the significant difference growing, or how different the world is if you're in a low growth, so say 0 to 2%, or if you're in a high growth, because that means even in the time that you begin secondary school and end it, the whole economy will nearly have doubled. So that's just an example of something that you can do using logs, because the relevant plot here was this. You just plot log 2 over log of 1 plus 0.01, because that's the percentage, x. So just show where that came from. If you're growing at p% every year, then after x years you'll be 1 plus p to the power of x. And I wanted to know how many years, what x will lead to the economy doubling. And with logs, which is what we're going to look at next, we just go log both sides. So then I'll end up with log x log 1 plus p is equal to log 2. So then that means x, the number of years, is log 2 divided by log 1 plus p, where p is percentage growth. And that's what we plotted. How do logs work? Basically, just look it up in your tables book. So it's all there. So you don't have to memorize it. Well, the typical example would be something like this. So you have 2 to the power of x is equal to 5, and you want to know what is x. So the way you do it is you take the log of both sides. So you get x log 2 is equal to log 5. So x is equal to log 5 over log 2. Now, we haven't actually said any of this yet. I'm just doing the calculations like I do them, but we haven't actually shown how logs behave, that that you can go from 2 to the power of x is equal to 5, and then you end up with this step. So we are going to do that next. A concrete example would be if you take log of 5, and if you just type into Google, it's like log 5, it's something like 0.69897. So what's that mean? Well, that means that if you go 10 to the power of 0.69897, you get 5. Roughly, because there are more digits there, you'll get 4.9999999 and so on. You should really give the base. So, if you say log 5 and you get 0.69897, then I said 10 to the power of 0.69897 is equal to 5. But that's because it's log to the base 10, which is typically the default. Though in other fields, if you're going to, if you're doing engineering and stuff, you'll probably be using natural log. And you can check that you are using base 10 by just typing in, what is log 10, and if it's log base 10, the answer is going to be 1. But this is basically what the log operation means. If you do log 5, it tells you the power that you raise 10 to in order to get the number. So now on to the actual building blocks. This is how logs are used, how you'll come across them. But these rely on you knowing how the operation works, which we haven't done. So normally you'd actually do the basics first and then show the example, but I thought I'd do it different this time, since it's pretty short. So the actual operations and stuff, they're all in your tables book. So you can look them up there if in doubt. So there are 3 types of things. So first, log base A of xy is log base A x plus log base A y. So basically, when you log a product, it becomes a sum, which is, what happens when you're dealing with powers. Remember when you did indices, you had, say, 10 to the power of x plus y is equal to 10 to the power of x times 10 to the power of y. So a product, once it becomes the exponent, it becomes a sum. Likewise, when you're dealing with division, you have x divided by y is log base a x minus log base a y. The next set of relationships is, and again these mirror what we did with indices. So log to the base a of a, well, that's equal to 1. I mean, if you're trying to get what is the log to the base 10 of 10, that's going to be 1, because 10 to the power 1 is equal to 10. Also, log to the base a of 1 is equal to 0, because 10 to the power of 0 is equal to 1, a to the power of 0 is equal to 1. So again, it follows from what we did with indices. So nearly done. Then there's log to the base a x to the power of q is equal to q log base a x, which is what we used at the start when we did 2 to the power of x is equal to 5. Take the log of both sides, the power falls down, so we get x log 2 is equal to log 5. The final relationship is when you're changing base. So it's just that log base a x is equal to log base b x divided by log base b of a. So that means that, if you wanted to find what is 10 to the power of x instead of 2 to the power of x, if you were switching bases, there's actually a pretty simple formula that lets you do that. So it's not hassle. So that's basically all there is to logs. They're not used that often, but they are very powerful. So, and there's not much to do. So basically practice with a few problems, and then you can kind of see, okay, that's all there is. And it is in the tables book, so you can kind of look up the specific relationships in case you forget.